Hi everyone and welcome to week 13 for higher level junior cycle. So today we're going to be looking at sets and different problems associated with sets. So we're going to be looking at some theory and then we're going to look at some exam questions as well pulled from papers. So if we are given two sets, so we've set A, which contains the numbers 1, 2, 3 and 4, and B, which contain the numbers 3, 4, 5, 6 and 7. We can see that there are two elements, 3 and 4, that are common to both sets. So we have the number 3 in set A and we have the number 3 in set B. We also have the number 4 in set A and the number 4 in set B. So when we're drawing a Venn diagram, we put the common terms in the middle. So we can see that we've put 3 in the middle and we've put 4 in the middle because both of those numbers you will find in A and in B. Now, if we look at the rest of what's in A, so we can see the numbers 1 and 2, and we put them outside the intersection part. So we put 1 here and 2 here, which shows the other elements in set A. Then the other numbers that we've left in set B are 5, 6 and 7, and we've placed them out here, 5, 6 and 7, and they're outside the intersection part as well. So this is a Venn diagram, and always start with the intersection part. So we're going to be looking at some notation now, so different types of notation that you will see in sets, and it's really important that you know what they mean. So the first thing, 2 is an element of A. So if you see the term 2, you'll see it kind of like an E symbol. It means 2 is an element of A, which means you'll find the element 2 in the set A. So that applies above because you'll find, as you can see there, you can see element 2 in the set A. If we go to the second bullet point, 2 is an element of the set 1, 2, 3 and 4. So what that means is 2 is in the set 1, 2, 3 and 4, and as you can see, it's in that set. The next thing, so 7 is not an element with where you have a line going through the E part. 7 is not an element of the set A, and it means that 7 is not an element of the set A, as you can see. Okay. So if we look at the shaded part of the next diagram here, so the shaded area below is called the union of A and B, and it's written as A union B. So A union B, so that means the set A and the set B together. And as you can see, it's shaded there on the diagram. So if we go to the next diagram here, the shaded area below is called the intersection of A and B, and it's written as ANB, like that. So A intersection B. So that means the intersection of A and B. Okay, so we look at the next diagram now. This is really important. So the shaded area below is called A less B. So A without B. It must be this area here because we know that the bit in the middle is the bit that's common to both A and B. So the bit A on its own is the bit that's shaded there. So A less B is what's shown there. If we go to the next one, if you see the term complement, or it'll be written, so the complement of A is written like this. So it means everything except A. And as you can see in the diagram there, everything except A is shaded. If we go to the next diagram, the shaded area below is the complement of the union of A and B, which is written as A union B complement. So what that means is everything except A union B. So everything that's shaded there is everything except A union B. Okay, the shaded area below is the complement of the intersection of A and B, written as A intersection B complement. So what that means is everything except A intersection B. Now I'm going to shade A intersection B in blue here. That's A intersection B, what's in blue. So everything in green is everything except A intersection B. The shaded area below is the complement of B, which is written as B complement. So B complement means everything except B. Now I'm going to do the same thing here. I'm going to colour in blue what's in B. All of this is B. So what's in blue there is shaded in as B. So everything that's shaded in green is everything except B. Okay, we're going to go on to an example now. So we're on to the second set of notes. So P is the set of divisors of 12. So the set P contains the numbers, all of the numbers that divide into 12. So 1 divides into 12, 2 divides into 12, 3 divides into 12, 4 divides into 12, 6 divides into 12, and 12 divides into 12. So that's the set P. Then they tell us that Q is the set of divisors of 9. So everything that divides into 9 is in the set Q. So the number 1 divides into 9, the number 3 divides into 9, and the number 9 divides into 9. So if we have to show this on a Venn diagram, which is what you're asked to do, represent these sets in a Venn diagram, the first thing you do is find out what's common to both. So as you can see there, you'll find the number 1 in both P and Q, and you'll also find the number 3 in both P and Q. And that's where we put it on the Venn diagram. So we put it in the intersection part, so we have the number 1 and the number 3, because you'll find them both in P and Q. Now, if we look at the rest of what's in P, so we have the number 2, 4, 6, and 12, and we have them labelled there. So 2, 4, 6, and 12, and that's outside the intersection part. Then if we look at Q, the only number that's left is the number 9, and we put the number 9 outside the intersection part, but yet still in Q. So that's how you do out a Venn diagram. We're going to do a harder question now, which is a real kind of higher level standard question. So I'm just going to scroll down here. So let's have a read through. A group of 100 students, now I'm going to underline that because that's your total, we need to keep that in mind. 100 students were asked if they had a presence on a particular social networking website, A, B and C. So this time we're going to be using 3 different circles for our Venn diagram. So 24 students had a presence on A only. Now that's really important, A only. 40 had a presence on B, and 50 had a presence of C, or on C. So we're told then that 14 students had a presence on A and B but not C. 18 students had a presence on A and C but not B. 8 students had a presence on B and C but not A. And then 4 students did not have a presence on any of the websites. That's really important. So the first part of that question, using X to represent the number of students who had a presence on all 3 websites, construct a Venn diagram and solve for X. And then the second part of the question, hence calculate the ratio of students with a presence on B only to the students with a presence on C only. So we're going to draw a Venn diagram here, but we're going to draw 3 circles to represent A, B and C. So you draw it like so, and I'm going to label it A, B and C. And I'm also going to draw a box around it. That's really important as well. So you draw a box around your Venn diagram. Now, let's look at the information that we've been given. We've been told that X is the number of students that have a presence on all 3 websites. So that is going to go in here. X is going to go in here because we know, sorry, that's a bit of a wonky X. We'll do that again. So we know that X is the presence of students of all 3, so I'm going to put an X there in the middle. Now there's a couple of other bits we can fill in. We were told that 24 students have a presence on A only, so that means it's not going to be in any intersection part. So we're going to put 24 here. Now we're also told that 4 students did not have a presence on any of the websites, which means that 4 is going to go out here. So there's another couple of things that we can fill in. So let's look at the first bullet point there. So 14 students had a presence on A and B but not C. So that's going to be A intersection B. So we're going to put 14 in here in between A and B. 18 students have a presence on A and C but not B. So the intersection of A and C is going to be 18. So I'm going to put 18 there. and then 8 students had a presence on B and C, but not A. So 8 is going to go in here. So we have as much information as we can put in there. And I've already dealt with the 4 students who did not have a presence on any of the websites. We put 4 outside. So we now have we're going to put in 2 more unknowns. We don't know the rest of what's in B. So I'm going to label this Y, and I'm going to label this Z, just for, we have 3 unknowns now. Now, we're also given some information. We were told that the total presence for B was 40 and the total presence for C was 50. So using these, we're going to generate some equations. So if we were to look at B only, so I'm just going to draw a circle around B. So we know that the total of B is 40. So if we were to add all of the elements of B, we would get 40. So I'm going to generate an equation here. So if we were to add everything that's in B, so 14 plus X plus Y plus 8, we would get a total of 40. So now we're going to rearrange the equation so that we have numbers on one side and letters on another. So X plus Y is equal to 40, take away 14, take away 8. You can put that straight into the calculator and you'll get an equation X plus Y is equal to 18. That's one of the equations. Now we're going to do the same, but for C this time. So I'm going to draw a circle around C here. So we're going to add up everything that's in C, and we are told that 50 had a presence on C, so we're given that information up here. So we're going to add everything that's in C. So we have X plus 18 plus 8 plus Z gives us the total of what's in C, which is 50. Now we're going to do the same thing here. We're going to put numbers to one side and letters to another. So I'm going to keep the letters on this side. So X plus Z is going to give me 50, take away 18, take away 8. Now you can put that straight into the calculator and you'll get X plus Z is equal to 24. So that's another equation. Now we can actually do another equation here. We have the total group of students. We were told that at the start, it's 100. So if we were to add everything together that you see on that Venn diagram, we would get 100. So that's what I'm going to do. I'm going to add everything I see there on the Venn diagram. I'm going to let it equal 100. So I'm going to add all the numbers first. So 24 plus 14 plus 18 plus 8. 24 plus 14 plus 18 plus 8 plus 4, don't forget about the 4 that's outside, and my letters, plus X plus Y plus Z give me a total of 100. So the same thing, I'm going to get letters to one side, numbers to another. So X plus Y plus Z is equal to 100, take away 24, take away 14, take away 18, take away 8, take away 4. So again, you can put that straight into the calculator and you'll get X plus Y plus Z is equal to 32. So now you have a third equation. Now I'm just going to number these equations. I'm going to number this 1, 2, and 3. So we have equation here, X plus Y is equal to 18. So instead of putting X plus Y in equation 3, I can put 18 in its place. So when I do that, so I'm just going to rewrite, instead of X plus Y, I'm going to put 18 plus Z is equal to 32. So we can now figure out what Z is. So Z is 32, take away 18, put that into the calculator, 32 minus 18 gives you 14. So we now know what Z is. So this figure here is 14. We can now substitute Z is equal to 14 into equation 2. So equation 2, I'm just going to write it out again. X plus Z equals 24. We are just after finding out what Z is. Z is 14. So X plus 14 is equal to 24. So X is equal to 24, take away 14. 24 minus 14 is 10. You've just figured out what X is. X is 10, and that's what you were asked to get in the first place. So the second part then, it says, hence calculate the ratio of students with presence on B only to the students with presence on C only. So let's just look at our diagram for a minute now. So we need to figure out what B only is. So that's going to give us Y. So if you add all of the figures up in B and take them away from 40, just double check that, yeah, 40, you will get what Y is. So Y is 8, and we got Z already, which is 14. So you need to now put that in a ratio. So it's going to be in the ratio 8 is to 14. Now, can we, so this is part 2, let's label it. Can we get that in a simpler ratio? Yes, we can. So 2 goes into 8 4 times, and 2 goes into 14 7 times. So the ratio there is 4 to 7. Okay, so we're going to go on to some papers now. So the first paper I have there is from 2013. So I'm just going to make it smaller. So this is question 3 from 2013, so we're going to go through it. Okay, so if we have a look at the first question here, for diagrams 1 and 2 below, shade in the named region. So we're being asked to shade in A intersection B intersection C. So that's going to be this area here where they all intersect each other. The second part, it's asking us to shade in A intersection B without C. So A intersection B without C is going to be this part here. So that's the A intersection B without C. Okay, so we'll go to the next part of the question. The box on the right contains 6 statements. Note that P dash is the complement of the set P. A number of the statements are incorrect. Write down one incorrect statement. So just looking at these, I'm going to go for number 5. So number 5 is A less B is equal to B less A. So that is not correct, and we're going to draw a diagram here or give an example to explain the choice. So I'm just going to draw a simple diagram, and I'm going to call this A and call this B. I'm going to put the numbers 2 and 4 in A, and I'm going to put the numbers 6 and 8 in B. I'm going to put the number 3 in the middle. So if I was to write down A without B, so A without B would be this area here. So they would be the numbers 2 and 4. Now if I was to do the same, but for B without A, so for B without A, it would be this bit here, which are the numbers 6 and 8. And that just shows you that A without B is not the same as B without A. So using a simple example like that, you can prove that that statement is incorrect. Okay, so we're going to go on to the next part of the question now. So this is going to be a Venn diagram. So a group of 38 students were asked if they had ever been to France or Spain. The number who had been to Spain only was 3 more than the number who had been to both countries. Twice as many had been to France as Spain, and 4 students had not been to either country. Find out how many had been to both countries. Okay, let's draw our Venn diagram first. So we've our 2 circles intersecting, and we're going to have a box around it. Okay, so I'm going to label this for France and this for Spain. Now, we are told that the total, I'm going to write this in the corner, so the total amount of students was 38. And what other information we're given? So the number who had been to Spain only was 3 more than the number who had been to both countries. Okay, so if we say, let's work with the intersection bit first. So we're not told how many had been to both countries. So I'm going to put the letter X in the middle there to resemble the number of students who have been to both countries. And I'm going to write that out along the side. So X is the number of students who had been to both countries. Now we are told that the number that had been to Spain was only 3 more than the number who had been to both countries. So if we had X was the number of students that had been to both countries, if it's 3 more than X, then what the number that's going to be in Spain is going to be X plus 3, because it's 3 more. So it's going to be X plus 3. Now let's look at this piece of information. 4 students had not been to either country, which means 4 is going to go out here. And then the last piece of information that you're given is that twice as many had been to France as Spain. Okay, so twice as many had been to France as Spain. So if we write down the total amount of students that were in Spain, so if we look at the whole circle there for Spain, it's going to be X plus 3, which is going to give us 2X plus 3. So the total amount of students that were in Spain were 2X plus 3. So the amount that had been to France is going to be twice as many as Spain. So twice as many as Spain is going to be 2 by 2X plus 3. Now this is really important. We need to take away the middle bit for this. It's going to be minus X, because we want to get the amount of students that were in France only. So that's a really, really important part, is that when you're figuring out this part here, that you take into account the middle part. You need to take it away. So we can now generate an equation. We know that the total amount of students were 38. So if we add everything that we have there together, so if we look at the first part in France, so it's going to be 2 by 2X plus 3 minus X, so that's what's in France, plus the middle bit, which is X, plus what's in Spain, plus X plus 3, and don't forget about the 4 on the outside. So plus 4 is equal to a total of 38. So we need to just, so 2 by 2X is 4X, 2 by 3 is 6, minus X plus X plus X plus 7 is equal to 38. So we're going to get letters on one side, numbers on the other. So 4X minus X plus X plus X is equal to 38. Take away 6, take away 7. Okay, so 4X take away X is 3X, 3X plus X is 4X, and 4X plus X is 5X, is equal to, so you can put directly into the calculator, 38 minus 6 minus 7, and you get 25. So 5X is 25, so therefore X is 25 divided by 5. So X is 5. So that's what you were asked to find out, how many students had been to both countries. The answer is 5. So I have another question here. Just to zoom in on this a little bit now. So this is 2014 paper 1. So we'll have a look now. So this is question 3 from 2014. So the sets A, B and C are as follows. So the set A contains the numbers 2, 3, 4, 5 and 6. The set B contains 2, 4, 6, 8 and 10. And the set C contains 1, 4, 8, 12 and 14. So you need to complete the Venn diagram. So the first thing we need to do there is find out what number is common to for A, B and C. So is there any number that you see there that you'll find in A, B and C? And straight away I can see the number 4. So 4 is in A, 4 is in B and 4 is in C. And there's actually no other number that's common to all 3. So I'm going to pop number 4 there in the intersection of the 3. Then we're going to look and see, is there anything that's common to both A and B? So for A and B, I see a 2 in A, I see a 2 in B, I see a 6 in A and a 6 in B, and that's it actually. So I'm going to put the numbers 2 and 6 in the A intersection B. So then I want to see, is there anything that's common for B and C? So is there anything that you see there that's in B that's also in C? So the number 8 actually, the number 8 here and the number 8 here. So that goes into the intersection bit for B and C. And let's just see, is there anything common for A and C? There isn't, so there's no number that's common to both A and C. So now what we need to do is write down the remaining numbers in A that we haven't dealt with already. So let's go back and look at A, so the number 3 and 5, so that's going to go in here, so the number 3 and the number 5. And then let's look at B to see what's left. It's only the number 10, so the number 10 is going to go out here. And then finally for C, the numbers that are left are 1, 12 and 14. So 1, 12 and 14. So that's the Venn diagram complete. List the elements of each of the following sets. So A intersection B. So if you look at A intersection B, you will get the numbers 2, 4 and 6. So that's really important that you include all of the parts of A intersection B. A intersection B is everything that's included there. Now the next part, B without A intersection C. So B without A intersection C. So if we write down first of all what's in A intersection C. So in A intersection C is only going to be the number 4 actually. So B without A intersection C is going to be 2, 6, 8 and 10. Okay, if we look at the next part, B less A union B less C. Okay, so let's find out what's in B without A first of all. So what's in B without A? That's going to be the number 8 and 10. Or the numbers 8 and 10. Now what's in B that's not in C? So if we look at the Venn diagram, what's in B that's not in C? So the numbers 1, B without C is going to be the numbers 2, 6 and 10. So 2, 6 and 10. So if we were to put that in one set, it's going to be the numbers 2, 6, 8 and 10. Okay, write down a null set in terms of A, B and C. Now I'll just write that down. So a null set means that there are no terms in the set. So the null set in terms of A, B and C. So we're looking to describe this area here. Now that area is going to be A intersection C but without B. So that gives us that part there. Now I'll just have a look at this part. I mightn't get finished due to time, but we can start it off and I'd finish it in your own time. So in a table quiz, 100 questions were asked. Team M scored 72 questions correctly and Team N scored 38 questions correctly. Find with the aid of a Venn diagram the minimum number of questions answered correctly by both teams. Now if we add the two terms together, so 72 plus 38, you actually get 110. Now there's only 100 questions were asked, so 110 minus 100 gives you 10, which means 10 goes in the middle. So see if you can figure out the last part. So you want to figure out what's in M and what's in N. So it should be pretty straightforward, and 0 goes out here. So see, can you figure out the minimum number of questions answered correctly by both teams. So I'll leave that as kind of a homework exercise, and I will speak to you next week.